Leveraging the Siemens Accelerator portfolio and the comprehensive digital twin, we are able to digitally validate a solid edge design using NX Mechatronics Concept Designer. We can use Teamcenter Share as our collaboration tool for sharing the solid edge design with our colleagues using NX. Our solid edge assembly can be directly opened in NX with zero translation. From here, we can access the MCD capabilities in order to add the physics necessary for this conveyor packaging system to run correctly. To start with, we can quickly define the bodies to be taken into account by the physics engine, starting here with the boxes, which will be defined as rigid bodies, and setting the weight appropriately. As we do this, we can also add the collision bodies or faces. These are the ones that will come into contact with other bodies in the simulation. All this information gets added to the physics navigator. We'll also define the chute as a collision body. When doing this, we can also add a transport surface, which allows us to determine how the boxes will travel down it. Playing the simulation shows the box correctly travels down the chute and falls off the end. We can now define the conveyor as a collision body and set its friction properties correctly too. And then define the transport surface to determine the direction and velocity. Another run of the simulation will see how things look now. Boxes travel down both chutes and along the conveyors, but they fall off the end. This can be rectified by defining the end plate as a collision body and then playing the simulation to verify it. Also, while we are here, we can configure the sorter as a collision body too, since currently the boxes just move through it. Now when we rerun the simulation, we can see that the sorter has a problem and the block is getting caught. We need to change the design to fix this problem. The design change can be communicated through the view and markup and measurement capabilities inside Teamcenter Share to our Solid Edge designer. We can even assign a task inside Teamcenter Share. Since this model was created in Solid Edge, we'll go back to the original assembly in Solid Edge and make the changes. With the Teamcenter Share integration inside Solid Edge, the model can quickly be opened and markups viewed without ever leaving Solid Edge. We will use synchronous technology to quickly alter the gap in the sorter to fix the problem. Just making the aperture 50 mm wider should do the trick. We can then mark the task as completed in Teamcenter Share. Once done, we can return to NX and update the assembly to see the changes. The associativity between Solid Edge and NX made this process a breeze. Playing the simulation again shows we fixed the issue. Next, we'll define a collision sensor, which will be used to trigger the push plate, which will then push the boxes onto the second table. Then we can define the push plate as a rigid body and a collision body, and then define the motion of the push plate by using a basic motion joint. Here we can also easily use a position control to configure the travel distance and when to move and how to move based on the collision sensor we just created. Let's play this again to see the result. Finally, we'll define the material flow and govern the rate at which the components get placed on the chutes. We want them to be placed at a rate of 1 every 5 seconds. Again, this is quick and simple to achieve. Then rerunning the simulation, we now see both boxes run down the belt together. With interoperability between NX Mechatronics Concept Designer and Solid Edge, it has never been easier to verify how designs will work.